Okay, 9.1 is about the satellite. Okay, let's see the topics. Okay, there's one of the topic you can online to search some of the info, because I think this one just touching about the satellite for the surface only. Okay, let's see what is that. Okay, first one, you're going to see the satellite they want to introduce. A satellite, there's an object which is orbit the planet, or you say about the star lah, it just orbit. Okay, number two, they say, for example, the moon is a natural satellite, okay, which are orbit the earth. So from here, they just introduce for you. The first one, we are normal to know one. Then we every night, we also can see one. There's a moon. Moon is one of the satellite that just orbit the earth. Okay, then there are many of the man-made satellite which orbit the earth. So the moon should be the natural one. Then the others, because so many, there's a man-made. Okay, so now we're going to see what is the man-made satellite. Okay, the orbits of the satellite which are circle, okay, circle Earth, are grouped into the 5 types. Okay, we got 5 types according to the orbital height. Okay, so that means this one 5 types, they how to separate. They separate by the height, further from the Earth and closer with the Earth. So now we're going to see which are the 5 types. Okay, first one they call LEO, low Earth orbit. That means this one should be the nearest to the Earth. So orbit height is how many? Around 1,800 to 2,000 kilometers from the Earth. So we call it as a low Earth orbit. Okay, number 2, we got medium. Okay, medium means far a bit lah. Medium Earth orbit, we label by MEO. Okay, there's around 2,000 until 35,780 kilometers. So this one quite far already. Okay, medium Earth orbit. Okay, beside the medium, we got high, some more further. So this one we call high Earth orbit. So high Earth orbit means that already is over 35,000. So they say the orbital height is equal, or you can say that already exceeding over 35,780 kilometers. So from here, we go to learn about the 3. The name is almost the same: low, medium, and also the high. Okay, so you just remember around the range. Okay, how far, how high of the orbit. So you just remember around 1,800 until 2,000. So medium is 2,000 until 35,000. So the high Earth orbit means already over 35,000. Okay, after that we got man-made satellite. Number 4, there's a geosynchronized orbit. There's a GSO. The orbital height is 35,786 kilometers, and the orbital plane at an inclined angle to the equatorial plane. So that means the number 4, the plane must be slanted a bit, because they say that inclined with the equatorial. Equatorial means horizontal. Okay, our Earth horizontal. After that, this one is an inclined angle. So later I show you the diagram. So this one is an incline. So remember, for geosynchronized, they are the height almost the same like the HEO. Okay, but this one the pattern is inclined angle. Okay, then number 5, we got geostationary orbit, GEO. Okay, this one is your GPS lah. Okay, GEO. This one is an orbit height also 35,000 over, and also equatorial plane as the orbital plane. Okay, I go geostationary orbit. So this one is almost a equatorial plane. They seem like the Earth, the horizontal plane. So this one is a GEO. So what you need to remember the name. Okay, remember the name, remember the symbol. LEO, the short form, HEO, what is that? Then after that, you need to know where's the location. Okay, so that means 35,780, this one already is a maximum lah. So you see geosynchronized and also the geostationary, also this one high. Okay, they never over. Just the GSO, this one inclined with the angle, and the GEO, this one, there's a exactly equatorial plane. Okay, then we go and see the diagram. Okay, first one, LEO. Okay, this one is a LEO. There's a closer with the Earth. Orbit height is around 180, is it? Okay, 180. I just now I label 1,000. Suppose it's a 180 until 2,000 kilometer, means very, very close already. Okay, you follow the textbook, 180 until 2,000 kilometer. So means very close lah. Okay, number 2 is a medium one. Okay, medium one, you can see the orbital height 2,000 until 35,000. Okay, quite far already. Okay, now we see the height one. Okay, the high Earth orbit. Okay, there's an equal 35,000. They also can be over. Okay, so this one is a 3 different height of the orbit. Another one. Okay, can you say just now? I told you there's a Sanyet orbit. So this one is a GSO, geosynchronized orbit. The height is a 35,000 or more. Then after that, orbit plane must be inclined angle. So you can see this as an inclined angle with the equatorial. Equatorial means the horizontal of the Earth. Okay, so now we show another one, GO. The one is exactly equatorial. We go and see the shape. This one we call equatorial. Okay, so you can see the purple color, this one GSO, they already sang it with the equatorial. So this one, the green color is a geostationary orbit. There's a GEO. Okay, the height also same. And also the equatorial plane is orbit the plane. So there is exactly equatorial to orbit the Earth. Okay, so you need to remember these 5 of the orbits. Okay, of the satellite, how they go to move it. Okay, so now we go to the next orbital shape. Just now you can see so many shapes. Okay, now we want to separate the 5 types to different shape. Okay, first one we got perfectly circular. That means there's a circle lah. Okay, another one is a elliptical. That means they're just like the oval shape, elliptical. So from here, this one we call perfect circular. Another one is an elliptical. Okay, now we go and see which one is an elliptical, which one is a perfect circular. Okay, GEO. Remember the GEO? Just now I told you there's a equatorial shape, the last one, geostationary. That one is a perfectly circular. Okay, perfectly circular. Okay, ellipse one. Ellipse, we got 2. MEO. Okay, the medium one, the blue color just now. MEO, the medium. And also the high Earth orbit. That one is the highest one. There's an elliptical. So that means I show you back the diagram just now. Okay, so the blue color medium, this one is an ellipse. And the red color, this one also is an ellipse. Okay, perfect circular. There's a GEO. The green color, this one is a perfect. Okay, now we left how many? We left the LEO and also the GSO. Okay, LEO and GSO, we see this one is under what shape? Okay, the last one. LEO and GSO orbit are perfectly circular or elliptical. So you can say there's a perfect circular. You also can say there's a elliptically because they're almost the same. Okay, we cannot say there's an actual perfect. There's a actual ellipse. No, there's a between. So we can say LEO and GSO, they got 2 choice. Either you can say there's a perfectly circular. You also can say there's a elliptically. Okay, so this one 5 types, different shape you need to remember. Okay, so now we go to the next part. Okay, apogee and also perigee. So you can see the diagram lah. Okay, we calculate by the equatorial. This one is a horizontal equatorial. Apogee is the furthest from the planet. So now it's the Earth. So that the apogee is a satellite located furthest from the Earth. Okay, perigee means there's a nearest to the Earth. So from here, we go to explain. The apogee of the satellite in an elliptical orbit is the positions of the satellite which is the furthest. Okay, paling jauh from the planets or the star, okay, and cycle by the satellite. So when you see the words for the apogee, mean there is a furthest one. Okay, another one should be the perigee. The perigee of the satellite in the elliptical orbit is a position of the satellite which is nearest from the planet or the star and cycle by the satellite. So differentiate what means apogees, what means of the perigee. Okay, we don't have left and right, just you see the distance. When the distance further, sure there's an apogee. When the distance is the nearest, we call it as a perigee. Okay, so this one is a location for the satellite. Okay, now we need to find relationship between the orbital height and also satellite velocity. I think this one you also got imagine. So when there's a nearest with the Earth, sure faster. Okay, sure faster. When it just further already, okay, further already, so that means the velocity will become slowed down. Okay, now we're going to see the relationship. The higher the orbital height of the satellite, the lower the satellite speed for it to remain the orbit. Just like just now, HEO, the high Earth orbit, that one is a further already. So that one should be the velocity slow one because they're already further from the Earth. So they say the higher the satellite you find, there's a lower the speed. Okay, when it just remain the orbit. Okay, now we go to explain why. Because the gravitational force, our Earth got gravity. They got some force to pull the satellite. So we call it there's a gravitational force on the satellite decreases. That means when you're far away from the Earth, you find the gravity become less. So when they become less, so that means the orbital height of the satellite should be increases. Okay, so this one is one of the reasons. Why further the satellite, they become slow down when they just move to the orbit because the gravitational force become less. So if you're closer with the Earth, example LEO. LEO is the lowest one. The one is near with the Earth. So that one should be, the orbiting should be the faster. So you think about that. We got planet, orbit the sun, is it? Earth is a number 3 one. So that means we complete to orbit the sun is a 365 days. So the planet that's more further from the sun, that means they take longer time to complete one circle. So that means the time taken should be longer. So the velocity becomes slow. So that's why they move very slow because they're already further. So from here, we're talking about satellite. Satellite is orbit the Earth. So that means when they're just further from the Earth, they will take longer time to complete the cycle. So from here, we're going to show, okay, this one is the Earth. So this one is a LEO. LEO is the most close with the Earth. So the speed is the highest. The speed is around 27,500 kilometers per hour. So very fast already, they go to road, go to moving. Okay, how about the MEO? MEO is a medium a bit. So MEO, the speed slow a bit lah, 13,900 only. Okay, so the HEO should be the furthest. Okay, so this one, the speed should be the smallest one. So that means you no need to remember the velocity is how many, but you need to know when it just further, the velocity will slow down. Okay, when it just closer, the velocity also will be increasing. So what's the reason? The reason is gravitational force from the Earth to pull. Okay, when you further, that means I cannot pull you more. You're so far already. So you closer, I pull you more, then you get move faster. Okay, so this one is a relationship between the height and also velocity. Okay, then we see the method how to send. Okay, sending the launch vehicle into the orbit. How you send the satellite to the orbit. Okay, you see, launch vehicle, which are made up of one or more rockets, okay, are used to send the satellite, or you say you want to send the spacecraft into the outer space. Okay, satellite you want to send until you go to the space. How to send? You might using the launch vehicle. So from here we got two way, okay, of the space satellite into the orbit using the launch vehicle. Okay, direct into orbit. Then Homer transfer orbit. Okay, let's see what's a direct, what's a Homer. Okay, this one is a one of the diagram. This one is a direct into orbit. How they go to send? Okay, first one, you can see the short video. Okay, they just send. This one we call direct to the orbit. That means they never hit to the Earth. After that, they continue to swing. Swing one of the circle orbit, then go back. So this one we call direct into orbit. They send the satellite straightforward turn orbit, then finish. So this one is a direct into orbit. Okay, now you see what means a Homer transfer orbit. Okay, this one's a direct. You can see, refer your textbook. Rocket trajectory, when they just send the straightforward follow the orbit, then the satellite will moving to this orbit. They never move to other way already. Okay, the Homer one. The Homer transfer orbit, you can see the first round, they go to send. Send small orbit first. Okay, send the small orbit. Then when they just move to the green color, they will run, burning at the perigee. Okay, perigee, that's the nearest one. Okay, they're burning at the perigee. After that, they go to Homer transfer orbit. Homer transfer orbit means they just jump to another orbit. When starting small orbit, then after that, they jump to the another small orbit. So from here, they go through the Homer transfer orbit. Then they continue. After that, they jump, burn again at the apogee, then jump to the large orbit. That means they're not straightforward, go to the large orbit. They are slowly, small orbit first. Then after that, they need to burn, help to more energy to jump again. So they jump to the Homer transfer orbit. Then they continue to burn again at the apogee. Then they jump until to the large orbit. So that means they're using 3 steps. Okay, finally they reach to the orbit. Okay, so this one we call Homer transfer orbit using more steps. Directly means straightforward jump until to the bigger orbit. So this one is a 2 different way how they go to send the satellite to the space. Okay, they're using what to send? Now we go and see what is the launch vehicle. Okay, this one they show you how they're using the Homer transfer orbit. Okay, you can see they produce the burning when they go at the apogee and also the perigee. You see, when they just go, they will fire. When they fire, that means they start to want to turn another orbit. So this one is a Homer transfer orbit. So just like this one diagram also same. This one is the Earth. When starting, they go to the low Earth orbit. Okay, after that, they go to burning. Then they want to jump to the Homer transfer orbit. And the last one, they jump with the largest one. Largest is a geostationary orbit. Okay, so this one is how they go to send the satellite. Okay, remember the name, direct and also Homer. Okay, now we go to see launch vehicle. Who help to send? Okay, we got two types. Okay, first one we call expandable launch vehicle. Another one is a reusable. Okay, expandable like this, just like the rocket. Okay, the rocket, when it just send, then they will come back. Okay, straightforward, go there lah. Okay, then after that, all the rubbish all in the space already lah, if the thing never use one. Okay, so this one is a reusable. Reusable means after you send, they will come back. That means you can reuse for the next time. Okay, ELV only one time. You just send, just go there already. They cannot come back one. Okay, so it's a normally using for the rocket lah. This one is a spacecraft. When it just send, that means after sending all the things, they will come back. So this one we call it as a reusable. That means the next time you can reuse again. So for this part, this one is an expandable only one time to send, then that's all. Okay, so this one is a 2 launch vehicle to send the satellite to the space. Okay, remember the name, okay? Then you need to know which one is a one-time, which one can be reused. Okay, so we go through to the next. Okay, this one is a ISS, the International Space Station. They're just like the one station in the space. Okay, just like you got bus station, is it? You got monorail station, is it? That one is the thing that you want to take monorail, you go to monorail station. Then you want to take the bus, you go to bus station. But this one is a space station. That means you go to the space, they got one of the station for you to stay there. So this one we call ISS. Is the result of the effort from the 5 space agency. We got 5 agency to build the ISS. So this one agency, first one from NASA, okay, America one. After that, we got Roscosmos from the Russia. Then we got JASAT from the Japan. Then ESA from the Europe. And the last one is a CSA from the Canada. So these 5 agencies, they help, okay, combine together to build the station. So this one we call station international in the space one. So they're labeled by ISS. Okay, so anybody astronaut then just go there, they will parking at there lah. That one is one of the station for that. Okay, our Dato Dr. Sheikh Mustafa Syukur, then everybody know lah. They already is first from the Malaysian that reached to the ISS. Okay, now you see what means of zero gravity. Okay, no gravity. Okay, you can see the diagram. This one is one of the indoor skydiving. Okay, they're just like no gravity. Okay, they got something to push you up. You never fall down one. This one we call zero gravity. So you can using this one activity to feel lah. To feel you just like go to the space. Okay, so from here, zero gravity, the condition is when no significant of gravitational force. Don't have any force to pull you down. You're only flying. Okay, for example, the condition is an indoor skydiving. Okay, so this one is a participant of the indoor skydiving that will float in the air and feel condition of the zero gravity. Okay, something to lift you up. So from here, why zero gravity? This one condition occur because the thrust means some of the force, they are very strong, okay, flow into the air upwards. So they want to push. The force is very strong to push you up, okay, on the participant. Finally, they're equal to the value of the weight. So that means this one force same like your weight. So what happened for you? You cannot come down already because they're same like your weight. So you just floating, okay? Floating in the sky, just like this, okay? Because the force acting up, then your weight is acting down. So opposite direction, then you are balancing, okay? So that means you are flying. So this one we call zero gravity. Okay, now you see one of the short video that just like go to the space, okay? That means they cannot stand properly. Okay? They just keep falling. Okay, because there is a no gravity. So you want to walk very, very hard. Okay, they want to walk also very hard. So you can see, they want to move. You see, they're not balanced one. They cannot touching the ground. So this one is one of the example for zero gravity. Okay, so this one is what happened when they just go to the space lah, because we don't have any the gravity very low already. We cannot say no lah, they still got gravity, but very, very small because you are further already. Okay, so they cannot stand properly for these situations. Okay, then we go impact of rapid development in the space technology. So that means this is one of the things they want to develop. Okay, develop the space in the technology. So this one is one of the disadvantages. We see what's the disadvantages. Increase the waste in the space. Okay, when they just want to develop the thing in the space. That means they will send the satellite, they will send the spacecraft go to the space. But this one, they will create the rubbish. Okay, something can use, something cannot use. So something cannot use, go where? Still in the space lah. So this one, they say they increase the waste in the space. So this one we call space junk. Okay, space junk. Never use one. Okay, because they cannot go anywhere. What? Okay, the used one they use already, but not using one, they become the rubbish in the space. So you become the diagram like this. They got so many things outside. Okay, so that means when the satellite just move, they need to avoid collision. Okay, collision with this one, space junk. So from here you can see waste in the space, or you say it's a space junk, are the non-functioning satellite. Okay, maybe the satellite cannot use. Okay, they also left there. So they use a part of the ELV. Okay, remember the ELV, just now I showed you the rocket. The rocket just sent out, they never come back one. So that means can use one, then the satellite can be used. If the satellite cannot function, they just leave there. Okay, when they just leave there, they become rubbish. So we call this one is a space junk. Satellite debris from the collision between the satellite exhausted the rocket and other waste. Maybe the satellite, they will langgar collision with another satellite. Then they produce the thing also is a rubbish. Okay, so these all, they are inside the space. So that means when they just rapid development, they will create the rubbish more in the space. So from here, the more space junk there is, the higher the risk of collision satellite with the space junk. Okay, if you more rubbish, that means the satellite, they are more easy to be hit to each other. So from there, they say this one explain why the weather satellite, okay, weather satellite, normally they changes the orbit several times. They never follow the orbit. Sometimes they changes. Why? Because they avoid to collision with the space junk. Okay, when they just move, normally it's follow the orbit, is it? Sometimes they will move. Okay, for this one, weather satellite, they will moving one. Okay, so that means they want to avoid to jump to collision with this one, space jump. So that's why they want to move it. So this one is one of the reasons. Okay, increase the research and development activity. Okay, sure, got pro and also con, is it? Just now I said disadvantages. Okay, but we still got advantages when we're using the research for development activity. Okay, advancement and also development in the space technology have increased activity in research and also development in the various field. Okay, what field they go to develop? First one, they say human health. Then number two, respond towards to the climate changes. Okay, and also disaster. That means they can control. You got to find out why it become like this. Why they got climate change. Then why they got disaster, bencana. Okay, too hot, suddenly too cold. Why become like this? So this one, they want to find out the what to reduce this all thing to happen. After that, they got new innovative for technology. Maybe the next round you can go there and travel. After that, they got global education about the global warming. Then and also development in the space economy. These all things we do know. This one is a future thing. Okay. Okay. Old style. The example your grandmother, grandfather, they also do know can using internet. What is it? So until your level already, that means now you say, oh, internet is a biasa already, like everybody know, is it? But that time, they not assume we can use it. But now you can use it. Everyone in the house, you also got handphone, you also got laptop. So this one is a future thing. We also do know. Maybe your grandchildren, later they go to space to travel. We also do know. Okay, so this one is a future development. So must somebody to be developed this all technology. Okay, if not, we cannot to improve our life. So normally This one is depend for the scientists lah. Okay, so this one is about the satellite topics. Okay, so from here I got prepare one of the Google form for you to fill in. So today the task should be the 9.1 formative practice. I think there's a no problem, 1 until 5 questions. There's a related what I teach today. Okay, later I will share about this video in the Google Classroom, so you can refer back. Then this one question you need to copy in your exercise book and answer it. So our lesson just until this part lah. So everybody, hopefully you understand. If not understand, you refer back the video. Okay, everyone, bye.